Two of the problems are worked out on that answer sheet, so use it to benefit you, to help, so that you can kind of look to see if you get stuck. Where did I go wrong? But again, the answer sheet for this assignment, because there's even and odd problems, I have it attached directly to this assignment instead of you looking at the back of the book. So we're going to look at the homework assignment from last night. So section 1, 2, this is like day 1, starting on page 24. And I'm going to talk about questions 51 and 53. And then I also wanted to look at 82 and 83, and we'll do probably one of the two of those problems. And then if there's time at the end of class, I might come back to it, the other one that I might not get to. So questions 51 and 53 ask you to find the inputs that have outputs of 0. So then it explains it a little more. It says find all the values of x such that f of x is equal to 0. So our goal is to find the x values. So I want to find the input values that have an output value of 0. How would you solve this type of problem? How would I find x if f of x is equal to 0?
You set the equation equal to 0?
Yeah, you set the equation equal to 0. So if it's saying f of x is 0, that means I take f of x out and I replace it with 0. That's what equals means. F of x is equal to 0. So I'm going to replace it with 0. Our goal is to find x. So if I'm trying to find x, I can't plug a number in for x because that's what we're trying to solve in this problem. So if I'm finding x, I know 3x equals 15 or x equals 5. So I actually have found the x-intercept because I set the equation equal to 0. Well, when y is 0, I'm finding the x-intercept. Just a different way of thinking about it. So something we've already done, yes. Is it in function notation? And last chapter it was in y equals? Yes. But it's not a different process. So you're taking f of x, replacing it with 0, and then solving for x. So that's what 51 and 53 were asking you to do. The other group of problems that I said I was going to talk about were these difference quotients, and these are the big ones. So your first quiz that you have on this group of material is on Monday, from like the concepts we're going over this week. You will not have a test or a quiz question on this concept yet. You'll have a test question on this once we get to the halfway point of the chapter, which will be when we're back in the real life classroom and not, well, half of us are, and not all of us learning remotely. So this is a concept that we will continue to work on all chapter and we'll continue to practice. You were assigned 82 and 83, so I thought I'd look at 82, the even problem, because it has a G instead of an F. And we're dealing with the equation 3x minus 1. This wants you to find the difference quotient. That's what each one of these are called. And yes, I know they all look a little different because like 81 has a plus C, and then 82 has the G, x plus H, 83 has a 2 thrown in there. But the form of it is called a difference quotient, and that's because the top is difference, and then the whole thing is a quotient or a fraction. That's how it gets its name. So if we look at 82, we're trying to use the equation 3x minus 1. Remember, that's our function. The difference quotient part is what we apply to the function. So when I see this g of x plus h, the g part means I need to go into the g equation and replace x with whatever's in parentheses. So I'm going to do a little side work. You don't have to do this side work, but I kind of like to organize my information. So I'm going to do that, the first step here. I'm going to call this step 1. So in my equation, 3x minus 1, instead of x, I'm plugging in or replacing x plus h, substituting x plus h in for x. And then I have the minus 1. That's what the g part means. It means go to the function g, replace x with whatever's in the parentheses, that quantity. And then if I simplify this, this becomes 3x plus 3h minus 1. So this part here represents g of x plus h. The second part is saying take negative g of x. So this is part 2. So I'm going to do negative g of x. Well, that means, again, I'm using the g of x equation and I'm making it negative. So my g of x equation is 3x minus 1. I need to make that whole thing negative. So now it's negative 3x plus 1. So this here represents negative g of x. So if I take those two pieces and then combine them back on the top of the fraction, so I have part 1, part 2. I'm going to write that back on the top of my fraction. So 3x plus 3h minus 1, that was part 1. Now I'm going to plug in part 2, negative 3x plus 1, and then all over h. So this is like scratch work. If you don't need to show that scratch work, that's fine. You can just keep it all on the top of the fraction, depending on how comfortable you are. And as we work through more of these, I think you'll get more comfortable with the concept and doing that like substitution. It really is substitution into a function or evaluating a function. So Brenna, if we look at my expression, now I have this difference quotient. I took the part 1, the part 2, plugged them together in an equation. What can we do with this difference quotient as it's listed, Brenna?
You can combine the top, and you can eliminate 3x and negative 3x and negative 1 and 1.
Excellent. So I can eliminate that stuff. They're opposite terms, a positive versus a negative. So they eliminate. What we have left is just the 3h over h. And then, Brenna, what can I do with those pieces?
Can't you make it 2h? Because you can take an h out.
We can take an h out, but when you have a fraction and there's something in common, this h underneath has a 1. And remember, the numbers stay together, so that's really 3 divided by 1. The variables stay together, and they actually cancel, because it's like having h divided by h. So they just cancel out, because that's that common term. They're gone. So it does nothing to the coefficients in front. It just cancels the variable behind it, because the variable is the same. And that leaves us just with a 3. So that means this difference quotient simplifies to just be the number 3. Now, if you were looking in the back of the book, along with that 3, they also stated that h can't be 0. And I know you're thinking, well, there's not even a 0 left in my answer or an h left in my answer, so why do I have to put that there? Well, the reason we need to place that in the original problem is sometimes you're asked to evaluate for that value of h. So as I said, as we grow through this class and move through this class, we're going to be given numbers that represent h. And if you're given a 0 to start off with at the very beginning of the problem and they ask you to evaluate when h is 0, it cannot be done. So that's why even in the answer, I need to include that as part of the answer. The reason I have to include it is because h is in the denominator and I can't divide by 0. So if I was given a value of h, I'd have to say the problem can't be solved because I can't divide by 0. So there would be no solution. It wouldn't be simplified further. So again, right now we're trying to learn the process of evaluating. As we move on and get more into the math and the pre-calc, we'll learn all about this. So it's not something that we're just doing now. We're going to learn it throughout the whole year. And at the end of the year, we're going to come back to it and you're going to be like, oh, that's what all that meant. Any questions? Okay, so we're going to go into the notes. If I have time, I'll come back to 83. But you're going to do a couple more problems, and we're going to do one in the notes similar to number 82. So again, the goal is to kind of just get comfortable with the process, noticing how terms cancel out, how the h's cancel out, and that is consistent with this type of problem. That's what they have in common. So the problems are kind of set up like that for things to cancel because of that difference in the end, that minus f of x or minus g of x. So if you could take out your notes and look at section 1, 2. So we're working on this. So I was at 1, 2. Working on this yesterday. We're going to see if we can do this difference quotient again in example 4. And then we'll look at piecewise functions and we'll talk about domain and range. So example 4, there's two things that we need to focus on. We need to first focus on the function. And then we need to look at the notation that they're using in the difference quotient. And noticing that we have an x plus c instead of an x plus h. But that doesn't change the way we approach the problem. So I'm going to take the first part of the problem, that f of x plus c. Remember, that means you go into the function x, or in for x in the function f. So I'm going to write a little step 1 over here. And I wrote an h instead of a c. So I'm using my function 2x, but in place of x, I'm using x plus c. That's what the parentheses means. F of x. F of whatever replaces x in my function f. And then I distribute and I end up with 2x plus 2c. So that's my part 1. So now I'm going to take that other part and it says subtract f of x. Well, f of x is 2x. I'm supposed to subtract it or make it negative. A minus sign and a negative are pretty much the same thing. If it's negative, I'm really subtracting it. If it's a minus, I'm making it negative. They're interchangeable. So here's that second part. So if I take those two pieces and combine them together, that makes my difference quotient. So going into the fraction, I'm going to take that 2x plus 2c. That's the first piece. Then I'm going to take my second piece, which ended up being negative 2x. So I'm taking these two pieces, combining them together on the top. And then I have divided by c. So Darby, what do you notice about the top of this fraction?
You can like cancel stuff out because there's like terms, so 2x can cancel out and negative 2x can cancel out.
And then if I have 2c divided by c remaining,
you can cancel out the c's and the answer will be 2.
2. So the answer is 2, very similar to the one that we just did in the book. So again, I'm evaluating this function. It's just we have multiple pieces that we're evaluating. The last part, there is a c in the denominator, so part of my answer has to say c cannot be 0. And I know that it isn't there. There's not a c in my answer of 2. But again, I could have also been given initial directions or more information about this problem, and if they gave me initial information that c was 0, then I'd have to say, oh, can't do the problem, it's undefined. Any questions on the difference quotient? So you'll have more problems to practice tonight. I think on Friday there'll be a couple more for us to practice. On Monday there'll be some for us to practice, and like just continuing on. We'll just keep working on these. So this second thing that we're going to look at today is that piecewise function. Jack, do you remember a piecewise function?
Yeah, it's where based on the value of x, you choose which one to use.
Yeah, good definition there, good explanation. So he said based off the value of x. Well, here are my x's. And in the notation, remember x is in the middle. You choose which function or which piece to use. So a piecewise function are really portions of equations, portions of lines, portions of graphs. It's not the whole graph, but it's a half of it or a third of it, depending on the information that we're given. And when you evaluate a piecewise function, you pick one piece, dependent on the x value that you're given. So my piecewise function says f of x is equal to x squared plus 2. That's one piece. My second piece is 2x squared plus 2. Next to it is a condition. And the condition for the first equation is when x is less than or equal to 1. So I would choose that piece for all of the values where x is less than or equal to 1. My second piece works when x is greater than 1. So again, I have to look at x and decide which piece am I using based off of the x value that they're giving you in the question or in the problem. So this says evaluate the given function for the following values. And letter A, we have f of -2. So again, this is my x. I have to look at that x and determine which equation to use based off of the two restrictions that were given. So you actually start with the restriction first, and then that tells you which equation you're working with. So if I have a -2 for x, Jenny, which piece of this function would we pick?
The top one,
And why would we use the top one?
because a negative number is always going to be less than a positive number.
Yeah, so my x is -2. -2 is less than or equal to 1. It matches that inequality. It holds the inequality true. So that means I'm using the matching equation, which is the x squared plus 2. So pretty much my x tells me which equation we want to pick, which piece of the function we want to use. And then I plug in the x value into that piece that we chose, and you evaluate. Evaluate means find an answer. In this case, I'm finding an answer for f of -2. And if I have -2 squared, it becomes 4 plus 2 makes 6. I should have one answer. You shouldn't have two. Yeah, I know there are two equations, but both equations don't work for my x because that x value is less than or equal to -1. So Jenny, if we look at letter B, our x value is +1. Which piece would you use if my x value is +1?
The top one, because it says or equal to.
Excellent. So 1 is equal to 1. So I would still use that top equation. So we're still using x squared plus 2. Well, 1 squared plus 2 is 3. So again, I don't have two answers. If I had two answers, then it wouldn't be a function, because then I'd have one x value and two y's, and that's not a function. So that's why I have one x value pertaining with one y, because it's a piecewise function. I'm choosing the correct piece. Looking at the last one, my x value is now 2. Well, 2 is greater than 1, so now I'm using 2x squared plus 2. So you're picking a piece of the function. Which equation do I need to use based off of the x value? So we actually compare x first and then choose the equation. And that last one should be a 10. So 2 squared is 4. When I multiply that by 2, I get 8, and then I add another 2. Questions? So your homework problems, yes, 43 and 39 had some piecewise functions in it. I'm hoping that some of you are saying, yeah, I did them correctly. Give myself a pat on the back, or give yourself a pat on the back. Any questions? So the other concept that we're going to look at is domain and range. And our goal is to use the function to find out the domain. Actually, not the range. We're going to just focus on the domain right now. We're not going to use a graph. So we're trying to use the function, the equation we're given, to determine the domain. Now there's two ways that the domain can be given to us. It can be given to us explicitly, or it can be implied. When it's given to you explicitly, the domain is literally given to you in the function. which means if I look at my piecewise function, notice the domain is given to us. We're going to be writing this in interval notation and not as an inequality. But that's a domain that's given explicitly. So anytime they tell you what x is, it's less than or equal to 1, it's greater than 1, then it's given to you explicitly. So I'm just going to give you an example of what one other one might look like. So if I had 3x minus 2, but then next to it, it said when x is greater than or equal to 2. This is the domain. It's given to me in the function. I would take it and write it as interval notation, but they're telling me I'm using a portion of that line, not the whole line. When it's implied, that's where you get to do the work. So the domain is going to be there. We're going to have to use the function or the parts of the equation to help us figure it out. And that's, of course, what we're going to talk about, because we need to think about what parts of the equation or the function help us determine the domain. So there are two examples underneath 6. Notice the domain isn't given, so that means we're going to have to try and figure it out using what we know about functions. So letter A says f of x equals 1 over x squared minus 9. This is a rational function. It's a fraction. So thinking about having fractions. Peter, what do you know about fractions?
You can't have a 0 in the denominator.
Yeah, you can't have a 0 in the denominator. So I know x cannot be 0. That means if we take that denominator and solve, then I know the numbers that x cannot be. So Peter, if we solve for 0 here, x can't equal what values, Peter?
3 or negative 3.
Yeah, nice. 3 or negative 3. So anytime there's a fraction, if there's something in the denominator, those are the numbers that x can't be. But those are the only two numbers that x cannot be. I'm going to go back to that number line because sometimes it helps having a visual. When we find the domain, we're going to find it in interval notation. So Peter said a negative 3 and a positive 3. It's not allowed to be those two numbers. But those are the only two numbers that it can't be. The domain is allowed to be any other number because any other number doesn't make the denominator 0. So if I look on my number line, that means the domain can be less than negative 3, it could be in between negative 3 and 3, and it can be greater than 3. How would you write that in interval notation, showing that it's allowed to be all of those intervals except negative 3 and 3? So think about interval notation. Look at the picture. How could I write interval notation for this number line? So how can I
You
write
could
an
do
interval? Peter, yes.
parenthesis, negative infinity, negative 3, and those both be parentheses. And then in a set of parentheses again, it'd be negative 3 to 3. And then it'd be, and you'd have like would
That
you have
little
the
U
U in
guy
between?
there. Yeah, good job.
I always forget about that.
Yeah. You'll get used to
And
it.
then you'd have, in another set of parentheses, well, you'd have the U, then you'd have 3 comma infinity in parentheses.
Nice job. Peter, can you explain why you put all those 3's in parentheses?
Because they aren't included.
Yeah, if it can't equal that, the way we show that it cannot be a number in interval notation is putting a parenthesis around it because it means that number isn't included in the interval. So now if I look at my number line, I have 3 intervals in the number line. I have the interval that goes to negative infinity, we have the interval in between, and then we have the interval in positive infinity. My number line matches the interval notation identically. We just have to understand that if it can't be a number, that's parentheses in interval notation. So graphing a little number line might help you try and write the interval. All right, let's look at the next one. Part B is a square root. So now we have to think about square roots. What do we know about square roots? What do we know about numbers in a square root? Jeremy, what do you know about square roots?
Can't be like square rooting a negative.
It can't be a square root of a negative, correct. So if I wanted to try and write that, if it can't be negative, what type of number could it be if it can't be negative? How could you think about that? Jeremy, do you know, like if a number can't be negative, then we would say it has to be bigger than what?
0.
Yeah, bigger than 0. Can it be 0, Jeremy? Can you take the square root of 0? You can. So it could be 0. It could be bigger than 0. So we're going to solve this equation to find the number where it would be bigger than 0. So what number keeps it positive? So if you say it can't be negative, in math, that really means it has to be greater than or equal to 0. So Jeremy, I'm going to pick on you one more time. What number would x have to be bigger than if I solve that little equation?
It'd have to be bigger than 4.
Yeah, it'd have to be bigger than 4 because I'd square both sides to get rid of the square root, which leaves me x minus 4 is greater than or equal to 0. Swing the 4 to the other side, and then we get x is greater than or equal to 4. So this is my inequality, but we need to write that as an interval. So if you need to, draw yourself that number line again. Here's 4. Just pick 4 somewhere on the number line. And it says bigger than, greater than, or equal to 4. So it starts at 4 and it goes on forever. So that's what the inequality is telling us. It's starting at 4, it's going greater than it, forever, above. So we need to write that as an interval. Olivia, do you know how you'd write x is greater than or equal to 4 as an interval?
Would you put? Oh my gosh, I just have brain blank. I can't remember how to do that.
Well, what number is it going to start with?
Would you start with a 4?
And then if it goes all the way bigger than it, what number would be at
And
the
then would it be positive infinity?
Yeah. And then if it's allowed to equal 4 because it says greater than or equal to, what do we put around the 4?
Would that be the parenthesis?
How about the
Or
bracket?
no, that would be the bracket there.
Yeah, that'd be the bracket. So again, looking at the number line, it starts at 4 and it goes on forever to the right. So 4 to infinity. So that would be my interval notation. So really, when we're looking at finding domain, there's really 2 things we're focusing on. Everything else is negative infinity to positive infinity. There is no restriction on x. So a little summary underneath, domain excludes values that make the denominator 0. So excludes means the domain can't have these values. Any value that makes the denominator 0, it can't be in the domain. And it also excludes values that make the radical negative. So those are really the 2 things that you need to focus on when we're thinking about the domain of a function. Does it make the denominator 0? If there is a denominator. Does it make the radical negative? If I can find those 2 numbers, then I should be able to find the domain without relying on a calculator. We're going to do 2 more problems with domain. So hopefully, like those 2 problems that we did, bringing back those memories from last year, thinking about the domain and interval notation, we're going to look at 2 more. So the directions say find the domain of the following functions. And if you look at letter A says A equals pi r squared. What is this function talking about? A equals pi r squared.
Area of a circle.
Yeah, this is the area of a circle. So it doesn't have a square root. It doesn't have a denominator. So based off of what I said above, there's no denominator, there's no radical. So I shouldn't have to think too much about the domain, except this is the area of a circle. So what do you have to think about with the domain? What letter are we focusing on? Because there's not an X in here, there's not a Y. What would be your independent variable? R, yeah. So we're looking at R. So in this case, we're thinking about the restriction on R. What can't happen with R if you have a circle?
Can't be 0.
It can't
or
be
negative.
0, and it can't be negative. So why is that, Jack? I think that was Jack who answered my question.
Yeah, because it's a circle, so it can't be like negative or
Because
0.
then our circle wouldn't exist.
Because
and
then,
it can't
yeah.
be 0 because our circle wouldn't exist. So if you have an actual tangible shape or object, and there's a radius in it, or if it was a rectangle and there's a length, my length can't be negative and it can't be 0, or my shape wouldn't exist. So that means that the r in this case, the radius of this circle, has to be bigger than 0. And sure, it could just be slightly bigger than 0, and then my circle exists. So it cannot be 0, which means I have to put a parenthesis. It's allowed to be bigger than 0, so it can go all the way up to positive infinity. So that would be the other exception. So yes, I want to look for a denominator. Yes, I want to look for a radical. But if it's an actual shape, whether it's a 2-dimensional shape or a 3-dimensional shape, we have to make sure that the length of that shape, the width of the shape, the radius of that shape also remains positive and bigger than 0. So the last question here, this was a good one. I threw in a square root and a fraction. So based off of my restrictions up above, I know that the denominator cannot be 0. So it excludes values that make the denominator 0, and it excludes values that make the radical negative, which means it has to be greater than or equal to 0. So if I find those two values, I should be able to try and write the domain. So if I start on the bottom and I solve for s cannot equal 4. So here's my number line. I'm going to put a 4 on here. Oops, I didn't mean to write it like that. Try again. Okay, there's my 4. Based off of the denominator, it's not allowed to be 4. So I'm going to cross off 4. Can't be 4. Now if I look at the numerator, this is saying the square root of s minus 1 has to be greater than or equal to 0. Well, really that means s has to be greater than or equal to 1 if I solve for the numerator. So on my number line, I'm going to place a 1. And it says it has to be greater than or equal to 1. Well, here's 1. Greater than or equal to means all in that direction. I have to take those two pieces and try and write the domain. So it has to be greater than or equal to 1. Not allowed to be 4. Ah, I lost my screen. Can somebody try and, oh, it came back. Try and write the domain using the picture. So it starts at 1. It's allowed to go all the way over and be greater than or equal to 1. But it can't be 4. So how would you write that as a domain?
Would you do 1 in brackets, comma 4 in parentheses, and then in union with 4 comma infinity in parentheses.
Nice job, Jenny. Why'd you think that?
Because it's allowed to be any number greater than 1, but it has to stop at 4. So you have to stop the values at 4 and then start it again to
Nice.
go all the way up.
Very nice. Good description. So it can be from 1 to 4, but it has to stop at 4. In math, when it stops at something, we use a parenthesis at that number. So it's almost like hopping over the number 4. So it's hopping over it. I then have a second interval. So the 4 is dividing it into 2 intervals. Questions? So the homework tonight focuses really on 2 things. It focuses on you finding the domain of a function by using the function. And then it also focuses on the difference quotient. Those are the 2 components tonight of the homework. Does anybody have questions? Okay. Have a fantastic day. We'll see you tomorrow.
Thank you. Have a good day.
Thank
Bye,
you.
Miss
You
Kane.
too.
See you
Have a
later.
good day.
Thanks.